Welcome in, everyone. Pull up a chair and get comfortable because you are officially the third person in our conversation today.
Yeah, it is great to have you sitting down with us.
We've got a really compelling deep dive lined up for you today, pulling directly from an instructional module titled Blockchain for Beginners Comprehensive Guide.
Right, and specifically, we are zeroing in on Module 6, which tackles enterprise blockchain and real-world use cases.
Okay, let's unpack this because the mission for our deep dive today is to look past the typical, crypto hype and analyze what blockchain is actually doing in the real corporate world.
Exactly. We're exploring not just the what, but the why. Why are massive corporations adopting a technology that was originally famous for cryptocurrencies?
Right, because when we hear blockchain, our minds naturally drift to public networks.
Yeah, Bitcoin, Ethereum, the volatility, or anonymous validators spread across the globe.
But the source material today completely bypasses that. We want to make these complex enterprise concepts approachable and relevant to your everyday life.
And looking at the module, the core problem that enterprise blockchain attempts to resolve isn't about creating new digital money. It's about a very human structural problem.
Counterparty trust.
Counterparty trust, exactly. That is the foundation of the entire enterprise argument.
Because companies, like suppliers, banks, regulators, they all have to work together, but they just don't fully trust each other.
No, they can't afford to blindly trust one another. Consider a standard global supply chain. You have raw material suppliers, manufacturers, freight forwarders.
Customs agencies, insurers.
Right, and financing banks. They all have to coordinate, but structurally, they do this by maintaining their own entirely separate siloed databases.
I imagine that creates a massive administrative bottleneck. It's essentially the corporate equivalent of a disorganized group project.
Oh, absolutely. Everyone is taking their own independent notes, using different formats.
And then the entire group spends 90% of their time just arguing over whose data is actually correct.
In corporate finance and logistics, they call that friction manual reconciliation. And it costs industries billions of dollars annually.
Wow.
Because each company guards its own proprietary ledger, they have to constantly sync up and verify data transfers. They hire third-party auditors.
Which is slow, expensive, and error-prone.
Highly error-prone. They rely on incredibly complex, often paper-based messaging systems just to prove that an event actually occurred.
And so enterprise blockchain offers a structural alternative to that traditional mess. Instead of 30 different companies running 30 disparate databases that constantly need to be reconciled, the blockchain acts as a shared, immutable, trusted record.
It provides an automatic synchronizer for all these competing parties. It solves those counterparty trust issues mathematically.
But we need to establish a really clear distinction here because there's a surprising fact from the module. Major enterprises are not running their businesses on the public Bitcoin or Ethereum networks.
No, not at all. There is a huge difference between public and private or consortium blockchains.
Because if I'm a massive retailer like Walmart, there is no way I'm broadcasting my proprietary supplier data to a public network where it's validated by anonymous servers.
Precisely. Public chains are designed for a trustless environment where anyone can spin up a node. Enterprise chains, on the other hand, use known, vetted organizations.
So they sacrifice true decentralization.
They do, and what's fascinating here is that you've just articulated the primary criticism from skeptics in the tech community.
Right. The critics argue that enterprise blockchains are basically just a shared database with extra steps.
Exactly. They call it blockchain washing. But the module pushes back on this. The trade-off is highly calculated. By limiting the network to known entities, you sacrifice decentralization to achieve thousands of transactions per second.
Which you need for corporate operations.
Right. You get thousands of TPS, near zero transaction costs, and high privacy.
And the source actually briefly outlines a few major platforms competing in this space, just so you know the landscape.
Yeah, first up is Hyperledger Fabric, hosted by the Linux Foundation. Companies like IBM, Walmart, and Maersk use it. It's permissioned and uses what they call private channels.
So if two organizations need to negotiate a confidential contract, they can spin up a private subchannel.
Exactly. Then there's R3 Corda, which was built from the ground up specifically for finance. It operates strictly on a point-to-point, need-to-know basis.
And Corda actually links its smart contracts directly to real legal pros. Right.
Yes, that is a massive breakthrough for contract law. It mathematically bounds the automated execution to actual legal liability.
That's incredible. And then the third one is Quorum, built by Consensus and JP Morgan, which is essentially enterprise Ethereum.
Right. It gives you high performance, over 2,000 TPS with private transactions while still tapping into the massive public Ethereum developer community.
And the Ethereum Enterprise Alliance, or EEA, exists to standardize that connection between enterprises and the public ecosystem. Seeing the architectural reasoning makes the real-world use cases so much more impactful, like the food safety example.
The mango example is a classic.
Yes. Back in 2018, there was a severe E. coli outbreak linked to romaine lettuce in the U.S. The legacy tracking systems were so bad it took investigators 11 days to trace the source.
And in a public health crisis, 11 days is catastrophic.
Completely. Contrast that with IBM Food Trust, which is built on Hyperledger Fabric. Walmart can now trace a package of mangoes from the store shelf back to the exact farm it grew on in 2.2 seconds.
From 11 days to 2.2 seconds, it's wild. That speed is the direct result of eliminating manual reconciliation.
And we see a massive reality check when we look at shipping and logistics. Moving refrigerated goods from Africa to Europe involves over 30 different organizations and hundreds of paper documents.
It is a logistical nightmare.
To solve this, Maersk and IBM launched the TradeLens project. The module notes that shipments of flowers from Kenya to the Netherlands arrive 3 days faster just by eliminating those paper bottlenecks.
But this raises an important question. If the underlying technology is mathematically and operationally superior, does that guarantee it will succeed?
That is the crucial reality check from the source. TradeLens actually shut down operations in 2022.
Right, due to insufficient industry adoption. It's a perfect lesson that superior tech doesn't automatically overcome political or business hurdles.
Because if you are Maersk's biggest global competitor, you're not going to integrate your proprietary data into a network governed by your rival.
The technology solved the database problem, but it couldn't solve the human monopoly problem.
Wow, yeah. But where incentives do align, it's working. In financial services, the We.Trade consortium cut trade finance processing from 10 days to same-day settlement.
And we see it in real estate, too. Prop B reduces real estate closing times from months down to mere days, which helps fight land registry fraud.
Okay, moving on to healthcare and identity. The concept of self-sovereign identity, or SSI, is huge. Right now, your medical records are fragmented.
The fragmentation is dangerous. Your GP, specialist, local hospital all have incomplete files. The module highlights MedRec out of MIT, which gives patients a unified cryptographic index of their records.
So the patient has control over who sees their medical history.
Yeah.
You explicitly grant or revoke permission.
Exactly. It completely inverts the power dynamic of data ownership.
And this SSI framework allows for things like zero-knowledge proofs, which is how you can prove you are over 18 without revealing your exact birth date to a bouncer or a website.
You're just handing them a mathematical guarantee. And companies like Microsoft with their ION network and the EU with its digital identity wallet are actively building this infrastructure.
Before we hit the limitations, we have to mention the energy sector. The Brooklyn microgrid by LO3 Energy is such a relatable example.
It really is.
Neighbors using a local blockchain to trade surplus solar energy directly with each other, totally bypassing the massive centralized utility companies.
It's brilliant, but we do have to establish boundaries. So what does this all mean? When should a company absolutely not use blockchain?
The Gardner test.
Yes, the module introduces the Gardner test. If a traditional shared database would solve the problem, blockchain is overkill.
So don't use it if you need millions of TPS, or if all parties already trust a central authority.
Or just for blockchain washing your marketing materials.
Right. And there is a major clash with modern data privacy frameworks, specifically the GDPR in Europe.
The right to be forgotten. You can legally mandate a corporation erase your personal data, but blockchain's whole value prop is immutability.
Right. Once a block is validated, it is sealed forever. You can't just delete it. So how do they work around that?
It requires a clever trick. They store your sensitive data off-chain in a normal deletable database. On the blockchain itself, they only store a cryptographic hash.
Like a digital fingerprint. So if you invoke your right to be forgotten, they delete the actual file off-chain. The permanent fingerprint remains on the blockchain, but the data it points to is gone.
Exactly. It renders the hash meaningless. They use that and zero-knowledge proofs to balance immutability with privacy laws.
Which perfectly brings us all back to you, the listener. We started this deep dive talking about massive corporate consortiums, but this hidden infrastructure is already impacting you.
It absolutely is.
From the safety and traceability of the fresh produce you buy at the supermarket, to the future of how your medical records and your digital identity will be managed.
It's a quiet revolution. But as we reflect on all this, I want to leave you with a final lingering thought that builds upon the challenges we've discussed.
Go for it.
If we move toward a world where your official digital identity is tied to a private, enterprise-run blockchain, what happens to your self-sovereign identity if the consortium of companies running that network goes bankrupt or decides to shut it down, just like TradeLens did?
Oh man, that is a profound tension right there. Owning your own data, but relying on a corporate consortium's infrastructure to validate it. Really great stuff. Well, thank you so much for joining us as the third person to this conversation. We appreciate you taking this deep dive with us, and we will catch you on the next one.